Okay, now let's move to the next section, 2.4.2, solving rational inequalities. Okay, 2.4.2, solving rational inequalities. Okay, for example, when we have example A, 2x minus 3 over x plus 1 is less than or equal to 1. So at the denominator we have an unknown that is x. So that is a rational equation, and the symbol of inequality is less than or equal to 1. Okay, when we encounter this kind of question, okay, rational, okay, you should never multiply x plus 5 with 1. Okay, you should never make it like this. So 2x minus 3 less than or equal to 1 x plus 5. Okay, you should never do this, because if you do this, then you will remove the denominator. Okay, from what you have understand from our previous topic, for first topic, for rational function, the denominator indicates the point of where the line of asymptote lies. So that's why you should never multiply x plus 1 with the 1 on the other side. Okay, you should never do that. Okay, what we can do is we take 2x minus 3 over x plus 5 minus 1 less than or equal to 0. Okay, then you make the denominator becomes equal, so it will be 2x minus 3 minus x minus 5 over x plus 5 less than or equal to 0. Then you will have x minus 8 over x plus 5 less than or equal to 0. Okay, so we have to come to the point where the equation has been simplified. Okay, so from the equation now we know x plus 5 cannot be equal to 0. So then x cannot be equal to negative 5. Okay, now we have x minus 8 from the numerator, and we have x plus 5 from the denominator. Okay, now I want to use a real number line method to solve these inequalities. Okay, real number line. Okay, so we have two sections. There is x minus 8, we make it bigger than 0. Okay, just what I told you for real number line. We take x minus 8, then we take another one that is x plus 5, we make it bigger than or equal to 0. So now we will have x bigger than 8, then we have x is bigger than negative 5. So we draw a line, we have negative 5, then we have 8. So x is bigger than 8, so means the arrow go to the right. Where the arrow goes, there goes the positive sign. So x is bigger than negative 5, it goes to the right, so positive, positive, and negative. So now the negative negative makes it become positive, negative, and it becomes a positive. Okay, now we return back to our last equation of inequalities, which is this one. We look at the symbol of the inequalities is less than 0. So means it wants a region that is negative. So our answer will be negative 5 until 8. Okay, you have to make sure that the negative 5 is open with a round bracket, because the x cannot be equal to 5 as what we write here. Okay, so that is how you solve a rational inequalities. Okay, now let's look at another example for rational inequalities. Okay, we look at example x squared minus 2x plus 1 over x plus 3. Now we have it less than or equal to 0. Okay, we have a quadratic. So what we do with the quadratic, we factorize it. So when we factorize, we have x minus 1. And we also have another x minus 1 over x plus 3 bigger than, less than or equal to 0. So the x plus 3 cannot be equal to 0, then x cannot be equal to negative 3. So now we have x minus 1 and we have x minus 1. So for that one, so mean we just take each of the factor, make it bigger than or equal to 0. Because we want to solve it by using real number line. X minus 1 bigger than 0. And another x minus 1 bigger than 0 because we have 2 of that. So x plus 3 is bigger than 0. So x is bigger than 1, x is bigger than 1, x is bigger than negative 3. Okay, so now we draw a line, negative 3, and we have number 1 right here. Okay, so for the first one, we have x minus 1. Go to the right, positive, negative, negative. Okay, then we have another second, x bigger than 1. So we draw another one, positive, negative, and negative. And then we have x is bigger than negative 3. Go to the right, and it becomes positive, positive, and negative. Okay, so now what we do is we multiply all of the symbols. So negative, 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 it becomes a negative sign. This here is positive, and right here is a positive sign. Okay, now we return back to our equation of inequalities. We can see here it is less than or equal to 0. So that's mean we want a negative region for our answer. So this will be the region. So our answer will be from negative infinity until negative 3. Okay, so it must be closed with a round bracket because x cannot be equal to negative 3. Okay, now let's go to the next section, that is 2.4.3, inequality involving modulus. Okay, so when we talk about modulus, so we know that a modulus can give us two answers, that is a positive and a negative. Okay, so that is first property of the modulus. That is written right here. Okay, what you need to focus on is the second and the third property of modulus. Okay, the second property tells us that when the modulus of x is less than a, okay, when modulus of x is less than a, it will give us x that is less than a positive one, and it will give us negative x that is less than a. What is important right here is to know that the relationship between these two x is n, because of the symbol of the inequality is less than. Okay, if the symbol of the inequality is bigger than a, okay, first we have to make sure that the x has a modulus with it. Okay, it also gives us x that is, x bigger than a positive one, and another one is negative x that is bigger than a. But the relationship between these two, positive and negative, is odd. Okay, these are the two things that you have to give more focus when completing solving inequality that involving modulus. Alright, now let's look at an example. We have an example of modulus 2x minus 3 less than or equal to 5. Okay, so now we want to break the modulus sign. We want to break the sign of the modulus. So we have a 2x minus 3 less than or equal to 5. That is for positive part. And we have another that is negative 2x minus 3. That is less than or equal to 5. So we can solve for this one. Okay, but first we look at this. The sign of inequality is less than. So that's mean the relationship between these two is n. Okay, just what I said before. So we can solve. So we have x is less than or equal to 4, and we have x that is bigger than or equal to negative 1. Okay, so for this one, so this means we have 4, it go less than 4, and we have negative 1, it goes bigger than negative 1. So when we bring these two together with the relationship of n, so we have negative 1, we have 4, so it will be the point of intersection between these 2 points. So our answer will be from negative 1, sorry, must be a square bracket, negative 1 until 4. Okay, so that is one of the method to solve modulus inequality by separating it into a positive and a negative part. Okay, there is also a second method to solve inequality with modulus, that is by square both sides of the modulus. For example, we have 2x minus 3, same equation, less than or equal to 5. Okay, in order to remove this square, this modulus bracket, we put 2x minus 3, we square both sides of our equation. So now we have 2x minus 3 square and we have 5 square. So as usual, we expand these two equations. So we have 4x square minus 12x plus 9 less than or equal to 25. So 4x square minus 12x minus 16 less than or equal to 0. So then we factorize x minus 4, x plus 1 less than or equal to 0. Okay, so next we do the real number theorem. Okay, real number theorem, we have x minus 4 bigger than 0. Okay, then we have x plus 1 bigger than or equal to 0. So this is so bigger than. So then we have x, this which is bigger than or equal to 4. X is bigger than negative 1. So we have negative 1, we have 4. So positive, negative, negative, positive, positive, negative. So multiplication will cause it to be a positive, negative, and a positive. So we back to our inequalities. We want a less than or equal to 0. So we choose a negative region. So the answer is still the same, which is from negative 1 until 4. Okay, now let's move to another example. We have a modulus of x squared plus 7x plus 6 bigger than 6. Okay, we try to solve this by breaking it into a positive and a negative part. Okay, if you want to solve it by square both sides of the inequality, you can try by yourself, and then you can compare the final answer whether it is same or not. Okay, so for positive part, we take x squared plus 7x plus 6 bigger than 6, and for a negative part, we will have negative x squared plus 7x plus 6 bigger than 6. Okay, so this part will give us x squared plus 7x bigger than 0, and for this one we will have x squared plus 7x plus 12 that is less than 0. Okay, before that, this is a modulus inequality. So the symbol of the inequality is bigger than. So back to the properties of modulus inequality that I have shown you at the early part of this section. If the inequality is bigger than, the relationship between the positive and negative part is an OR. So the symbol will be like that. Okay, so we can factorize the equation, so it becomes x plus 7 bigger than 0, and this one will become x plus 4 and x plus 3 that is less than 0. Okay, we solve this by using real number line. Okay, so I have x bigger than 0, x bigger than negative 7. So negative 7, 0, bigger than 0, positive, negative, negative, and bigger than negative 7 is positive, positive, and negative. So I have a positive, negative, and positive part. So my inequalities want a positive region, so we choose a positive region. Okay, so for the negative part, so I have x less than negative 4, and then I have x less than negative 3. Negative 4 and negative 3. So, oh sorry, this should be bigger than x bigger than, okay, because we want to solve it by a real number line, so we make it the factors become bigger than 0. Okay, so it should be bigger than negative 4, so positive, positive, negative, bigger than positive, negative, and negative. So we have a positive, negative, positive right here. So we want an answer that is less than 0, so we choose the negative part. Okay, so now we combine the two answers from two separate regions. So negative 7, we have negative 7, then we have negative 4, we have negative 3, then we have 0. So from the positive part, the region is less than negative 7 and bigger than 0. So from the negative part, the region is from negative 4 until negative 3. So that is our answer. So our answer can be written as negative infinity until negative 7 union negative 4, negative 3 union 0 until positive infinity. Okay, another example is modulus x squared minus 5x plus 3 less than or equal to 3. Okay, so we now break it into positive and negative part. So we should have x squared minus 5x less than or equal to 0. And we have x squared minus 5x plus 6 bigger than or equal to 0. Okay, so this is a modulus inequality that is less than. So less than makes the relationship between a positive and negative part is n with symbol n. So now we factorize. We have x minus 5 less than or equal to 0. And another one, we have x minus 3, x minus 2 bigger than or equal to 0. Okay, so now let's do the real number line method. We take x bigger than 0. We take x minus 5 bigger than 0. So for this one, we have x bigger than 5. So we have 0 and we have 5. So go to the right is positive, negative, negative, and go to the right is positive, negative, positive, negative. So we have positive, negative, and positive. What we want is a negative region. Okay, so another one is x minus 3 bigger than 0, x minus 2 bigger than 0, x is bigger than 3, x is bigger than 2. We have 2, and then we have 3, x bigger than 3, positive, negative, negative, and x is bigger than 2, positive, positive, negative. So now we have positive, negative, positive. So what we want is a positive region. Okay, now we combine those two answers with a relationship of n. So we have 0, we have 2, we have 3, and we have 5. Okay, so from the positive part we have from 0 until 5, and then from negative part we have from negative infinity until 2, and from 3 until positive infinity. So that's mean the line or the area that intercepts are in between 0 and 2 and 3 and 5. So our answer is from 0 until 2 union 3 until 5. Okay, so now let's look at modulus inequality that involve rational, that is x over x plus 4 is less than 2. Okay, so for this one we have x over x plus 4 is less than 2, so we break it into two parts, which is the positive and a negative. So then we have x over x plus 4 minus 2 less than 0, and then we will have x over x minus plus 4 that is plus 2 bigger than 0. Okay, so we expand that, we simplify, then we should have negative x minus 8 over x plus 4 less than 0, and the relationship will be n, and then this one will be 3x plus 8 over x plus 4 bigger than 0. So we know both sides have denominator that cannot be equal to 4. So we have negative x minus 8. We make it bigger than 0 because we want to solve it by using real number line. So x plus 4 bigger than 0. So we have x that is less than negative 8. So we have x that is bigger than negative 4. By real number line, we have negative 8 and negative 4. So for this one, x is less than negative 8. So less than means the arrow go to the lesser region. So positive will follow the arrow. So becomes negative and negative. So then we have x that is bigger than negative 4. Positive, negative, negative. So totally we have a negative, positive, and negative region. So what we need is a negative region. Okay, so now let's solve for the negative part. We have 3x plus 8 bigger than 0, x plus 4 bigger than 0, x bigger than negative 8 over 3, and x is bigger than negative 4. We have here is negative 4 and we have negative 8 over 3. So go to the right, positive, negative, negative. And then this one also go to the right with a positive, positive, and negative. So totally we have a positive, negative, and positive region. What we want is a positive region. So we know that the relationship between these two regions, these two parts are n. So we have here is negative 8, negative 4, and negative 8 over 3. Okay, so we should see which regions that are intercepts. So this is from the positive part, negative infinity until negative 8, and negative 4 until positive infinity. Okay, so next, from the negative region we have from negative infinity until negative 4, and then from negative 8 over 3 until positive infinity. So the regions that are in intercepts are in these two regions. So from negative infinity until negative 8, okay, union negative 8 over 3 until positive infinity. So these are our answer. Okay, so our final example, let's say we face with this kind of equation, x minus 3 modulus bigger than or equal to modulus of x minus 5 over 3. Okay, so the equation shows that there are modulus on both sides of the equation. So how to solve this situation is by using square both side method. Okay, we just take x minus 3 square bigger than x minus 5 over 3 square. Okay, just to square on both sides of the equation. Now we expand. So when we expand, we should have x square minus 6x plus 9 bigger than or equal x square minus 10x plus 25 over 9. Okay, so since the denominator is only a number of 9, so there is no any x or y, any variables at the denominator, so we can just bring 9 on the other side, multiply with the other 9x square minus 54x plus 81 bigger than or equal x square minus 10x plus 25. Okay, so we can simplify this, bring it all on one side, then factorize. You should have 2x minus 7 and x minus 2. Okay, when come to this point, you can just solve it as usual. Okay, symbol of the inequality is bigger than, so means the relationship is n. So 2x minus 7 is bigger than 0. Okay, and then x is bigger than 2. Okay, this one we follow the quadratic theorem. Okay, if we have a inequality with a symbol of bigger than, so means we have these two, a must be bigger than 0, b must be bigger than 0, or it could also be 2x minus 7 less than 0 and x less than 2. Okay, so from here we have x is bigger than or equal to 7 over 2. Sorry, it must be bigger than or equal. This one also. Okay, then we will have two and 7 over 2. So by basic theorem, 2 must be go bigger than 2, and then we have region that is bigger than 7 over 2. So since the relationship is n, so we look at the region that intercept. Okay, so for this one, it will be x less than or equal to 7 over 2, and x is less than or equal to 2. So it will be from 2, 7 over 2, less than 7 over 2, then less than 2. So the region that intercept is this region. Then we bring that 2 together, then we should have 2, 7 over 2 with a relationship of OR. So our answer will be this region. So we write our answer as negative infinity until 2 union 7 over 2 until positive infinity. So that's all for this section, inequality. So you have to focus on quadratic inequality. Okay, understand the theorem, a b bigger than 0. So you should know a must be bigger than 0, b must also be bigger than 0, or a can be less than 0 and b can also be less than 0. Then we have another second thing, that is AB is less than 0. So means one of A or B must be a negative number. So that multiplication of both will produce a negative. Okay, so then after quadratic, you should know quadratic inequalities can be solved by graphical method, can also be solved by analytical method. And then you should know about rational inequalities, that you should never multiply the denominator with another number. So, okay, because it will remove the asymptote from the graph. Okay, so we keep the denominator, then we simplify the quadratic at the numerator, find the factor, and then you can use either three of the method that I have told you, at the table of sign, real number line, or a basic concept. Okay, then next you have to focus about modulus. Okay, inequality that involving modulus. You should know if it has a modulus, so it can be solved by two methods. First, by breaking it into positive and negative part, or you can also solve it by use square on both sides. Usually, if the equation involving a quadratic, okay, you just break it into two parts, because if you square on both sides for quadratic inequality, so then you will have x with a degree of 4. So that will produce another problem for you to break it down. Okay, then you should understand whether to use the relationship of and or for modulus. Okay, for this one you have to focus on the properties that have been written in your reference book. Okay, make sure you understand that, remember that. Okay, for modulus of x less than a, so then the relationship between the positive and negative part will be n. And if the modulus of x is bigger than a, so then the relationship between positive and negative part will be or. Okay, I have shown you all of that and a lot of examples. So maybe that's all for the video that covers for subtopic inequalities.